And it's recording. All right, we go. Exercise 10E. Boys. Here we go. Exercise 10E. Your goal is to identify today just a couple of features from a quadratic graph. And then you're going to sketch by putting points onto a Cartesian plane and then identify them. So there's only two skills that you need to focus here. Let's have a look at our notes here. When you have y equals mx plus c, this was when you were starting at the start of this term when I first came. First half or so was on y equals mx plus c. This graph is, anyone remember, what does the graph look like again? Linear, which means what? Straight lines. Okay, so write in linear or straight lines. Okay, so one of the key things is noticing that the power of x at the moment, even though we don't write it, is the power of 1. So when it's x to the power of 1, you will get a straight line. Whereas so far, in the last 5 weeks or so, we've been working on quadratics, which is when it's x to the power of 2. And I'm going to show you on Desmos, so the difference between the shapes, but the name of this shape is called parabolic. So it's a parabolic shape, or you would say as a noun, parabola. Okay, so it's a parabolic shape, but it's got a parabola. That's the shape. That's what we call it. Rather than a straight line, then it is parabola. As you're writing that down, well, let's have a look at what a parabola looks like. So I said anything to the power of 2, right? So x squared. So I'm going to type in y equals x squared, which I already have on Desmos for you to see here. This is an equation y equals x squared. Put on a dot to say that I'm going to color it, and so it's in red. And what you see there is that's what a parabola looks like. Not a straight line. But notice what happens when I change the power. If I change the power to 1, then you get a straight line. So it really just depends on what the power is. So as soon as you have an x squared, and that's the highest power, you will get a parabolic shape. Okay, so at year 9, year 10, you're only focusing on linear and quadratic. Obviously, if you carry on with methods into year 11 and 12, then we'll look at things like cubic to quartic and quintic and all that. So you look at different shapes. You even look at to the power of half. So you might have something like that. That's what methods is about. So it's about the different powers that you're working with. But at year 9 and 10, building your algebra, we're going to do linear and quadratics. Okay? Now, let's have a look at a couple of features in this quadratic. In a quadratic graph, thanks. Actively listening or actively taking notes. What we can see here is that it's symmetrical on both sides here around this point. Okay, and so this particular point, the very bottom, so I'll move my mouse all the way to the very bottom here, right at the center, 0, 0, we give it a special name and we call that the turning point. So where does the graph change its direction? So you can see it goes all the way up, but if you come back from the left, it goes all the way down and then it goes back up again. There's a turning point, a point where it turns its direction. And so if you look at your example here then, where is my turning point in this graph here? Where is the point where it changes its direction? Where is that? Have a look at your graph. What's the coordinate of the point where it changes? Kaylee? 4 and, so this point here, yes, you're right, it's at 4, 4, 6, very good. It's at 4, and we can see the y value is at 6. So on your side over here, it says corner of the turning point. You would then say, well, x is 4 and y is 6. Write that down. So we know the point where the graph changes its shape. So I'm just going to draw it again in case you can't see it. This is the shape of the graph. There you go. So where does it change? At the maximum height there that it reaches, it's 4, 6. Now, when they ask you what type of turning point is this, can you see the language I was using that it goes up, 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 and it reaches a maximum before it goes back down? We call this, when we say maximum, this is what the shape of the parabola looks like. So that's a maximum. Whereas a minimum would look like this. This is when you reach the bottom, the minimum that it can get, and it goes back up again. This is called a minimum turning point, and this is called a maximum turning point. Okay, so you've got two pieces right there. The last one, which is interesting, every time I put on a test, I find that students get this one wrong. but they can get these ones right. All of these right. In fact, they'll get everything else right except for axis of symmetry. So I'm going to reiterate. And in fact, I did that to the other class this morning. And I said, you're going to get this wrong if you're not listening. And same thing again. They still get it wrong, even for those who are listening. It's a very straightforward idea. This is what the axis of symmetry means. I know it's a big word, but all it means is, where is this graph symmetrical? If you had to cut this, where would you cut this graph? And the logic is, it's right here. If I had to make sure it's symmetrical, I would cut right there, right at this line. And where is that? That's right at x equals to 4. So when they say, what is the axis of symmetry? You need to write down x is equal to 4. This is the line that cuts the graph in half. That vertical line is just the x value. We're just looking at, well, what's x? X is clearly 4. So it's just saying the axis of symmetry is at x equals 4. And I'm going to show you a few graphs and you're going to tell me where the axis of symmetry is, okay? It's basically where the graph is going to be symmetrical. That's why it's called axis of symmetry. Okay, so all you're looking for is where is it going to be symmetrical if I had to cut it. Let's have a look. I'm going to show you a couple examples on Desmos and you tell me where the axis of symmetry is, okay? So let's have a look. I'm going to take this graph away. Let's have a look at this one. If you had to cut this graph in half, where would you cut it in half for it to be symmetrical? At x equals 4. Let's have a look. If I did x equals 4, I type it in, that's x equals 4, and you can see that's my line. It cuts it. It cuts it literally in half. Let's give you another one. What if I swapped it and I did it this one now? So I'm going to take this away. What if I gave you well, not that one, this one? Where, if I had to cut it, where would my axis of symmetry be? X equals 2. That's it. This is where I can see right there. This is the point where I cut it in half. So if I wanted to cut it in half, I would type x equals 2. And you can see here, it cuts it right down. So that vertical line that you're seeing, that's called the axis of symmetry. So you actually have to write the equation, which is x equals 2. Okay, if you wrote y equals 2, it's not the same thing. Because if I wrote y equals 2, this is what it looks like. That's y equals 2. That doesn't make it symmetrical. It has to be x equals 2. That's when you get a nice vertical cut. Yeah? So, now that we've got that idea, I'm telling you, for some reason, later on, I'm going to do a bit of a test with you guys. See how many of you are going to get this one right, okay? Axis of symmetry is where you cut it in half. That's it. Turning point you already figured out. Where is the point where it reaches maximum and minimum? And the last two is pretty straightforward, very similar to linear graphs again. Where does this graph intersect on the x-axis? So x-intercept, looking at the graph, where does it intersect the x-axis? Have a look at your graph. It's on your sheet. Yeah, 2 and 6. But you never write just 2 and 6. To write it, you have to write the coordinates. And what are the coordinates of 2 and 6? Wait. Not now. 2 and 6. How do I write the coordinates of the x-intercept? So I can see it crosses the x-axis. This is my x-axis at 2 and 6. What are my coordinates? 2, 0 and 6, 0. Very good. So when they ask for x-intercept, don't write 6, don't write 2. Make sure to write the coordinates. And same thing, where does this graph intersect the y-axis? Yes, Avia? Very good. So at the end over here, this is where 0, negative 18 is. And that's where it crosses the y-intercept. 0, negative 18. Oh, all right, stop mucking around. Happens again, you guys are separating, yeah? I'm trying to teach. You're either actively listening or taking notes, but don't muck around. All right, here we go. So that's pretty much what you need to know for exercise 10E. Can you tell me x-intercept, y-intercept, turning point, and then lastly, the axis of symmetry? The type of turning point you'd be able to figure out just by looking at the graph, yeah? Let's test you now. So I'm going to go into the exercise 10E, and you tell me, okay? I'm going to pick a couple of students. Here we go. Let's pick the first one. So this is exercise 10E, question 1. Here we go. What's my turning point? What's the coordinates on my turning point? Let's go with Ava. Ava W. What's the coordinates of my turning point here? Where does the graph change its direction? Where's the point? Yeah, very good. This is called your turning point right here. It's 2, negative 1. So you got your turning point, 2, negative 1. Very good. Next one. Is this a maximum type of turning point or minimum, Jack? Minimum. Very good. This reaches the bottom, so that's a minimum. So you say type of turning point, it's a minimum. Great. Where is my axis of symmetry, which the one most students get wrong? Let's go with Lex. Where's my axis of symmetry? Very good. Okay, so axis of symmetry, you must say the equation, so it has to be x equals 2. If you just wrote 2, you'll be wrong. Because if you type that into Desmos, it doesn't draw a vertical line that cuts it. You actually have to write in x equals 2. Okay, so make sure that you write x equals 2. Very good. You got that right. That's axis of symmetry. And then the last two things. So you got a turning point. Now you need an x-intercept and a y-intercept. Tell me the x-intercept. Can I please have, let's go Elsie. Where's my x-intercepts?
1, 0.
Very good. And 3, 3, 0. Very good. Okay, so you got these 2 points. These are my x-intercepts. And the last one, where's my y-intercept? Let's go with, who haven't I picked? You want to have a go, Idris? Where does it cross the y-axis? You serious? Literally, this is the y-axis. Where's this graph cutting? At what number is it cutting? Yeah, that's it. It's at 3. See, when students tell me they can't do it, it's a lie. It's because you're not listening. This is all identifying. That's all you're doing. 1, 3, and that's 0.3, so it's 0, 3. Very good. So that's all you're doing. That was the first part of 10E. Yeah, so 10E is just asking you, can you identify those points? Yeah? So I'm pretty sure everyone here can do this. It's just a question of whether you want to do it or not. Now, can you all please turn on your notes? Can you turn over to the next page then? So how hard can 10E get? This is as far as 10E goes. 10E will then say, okay, so now you can identify graphs, but what if I want you to plot the graph? Okay, so how do you plot the graph? Well, right now you've got a blank canvas. Your job is to plot the coordinates for this rule. Y equals 2, whatever x is, you're going to square it, and minus 9. Here's a table of values. They say when x is negative 3, what is my y value? So you sub it into your rule and you figure it out. You say, well, okay, here's my rule. Y equals to x squared minus 9. If x is negative 3, I'm going to sub it in to find out what y is. So y is equal to, now let's work it out, negative 3 squared minus 9. What's negative 3 squared? Squared means times itself. So negative 3 times negative 3. Emma? 9. So then you have 9 minus 9, which gives you 0. Very good. So the 0 answer goes here. This is 0. Let's do it for the next one. If x was negative 2, then the y coordinate will equal to, according to the rule, you're going to square negative 2, and then you're going to minus 9. What's negative 2 times negative 2, Jack? 4, and then 4 minus 9, which I'm assuming that's what you were going to say? Yeah. The answer is negative 5. Very good. So you got y equals negative 5. Let's have a look. What about negative 1? So if you sub it in, same thing again. Y is equal to negative 1 squared minus 9. What's negative 1 times negative 1? KL. Negative 1 times negative 1. 1. Very good. So it becomes 1 minus 9, and 1 minus 9 is equal to what?
Negative 8.
Negative 8. Very good. So you write in negative 8. Let's have a look. What if x was 0 then? So again, I'll follow the same rule again. 0 squared minus 9. Now 0 times 0 we all know 0. What's 0 minus 9? Negative 9. Very good. So then I write negative 9. Now from here you should be able to see something special. Ah, yes. So if you put in 1 now, if you sub 1 in, you'll realize there's a pattern. If you tried 1 now, y is equal to 1 squared minus 9. You'll end up again, 1 minus 9 is negative 8, and you start to see a pattern. See this one over here and this one over here, they actually end up being the same, 1 minus 9 and 1 minus 9. So both answers end up giving you negative 8. And the reason why is because parabolas, remember I said it was symmetrical? So whatever happens to one side, it starts to look the same on the other side. So what we can see here is then that must mean this is going to be negative 8. This one would be what, based on the pattern? -5, and then what should this one be? 0. So if you plot in the coordinates now, well, a lot of students don't realize, but these are the coordinates. We're just putting in table form. It's easy to work out. So if you put out the coordinates, you've got, write this down, -3, 0. That's the first coordinate, -3 and then 0. Next one is, well, if x was -2, y was -5. Next one is, when it's -1, it's -8. When it's 0, it's -9. When it's 1, it's -8. And last two, -5. And your last coordinate is 3, 0. So what's the last part of exercise 10E want you to do? Sub it in. Now sketch. Plot the coordinates like you've learnt in year 7. How would we plot the coordinates and then sketch the graph? So I'm going to give you 90 seconds. Let's go. It is currently 15:54 minutes that I've been recording. Plot the coordinates and see where is my turning point, where's my x-axis intercept, where's my y-axis intercept, and you fill in the details. Let's go. I'm going to pause the video. I've got the graph up there, so even if you didn't plot it, at least you can look at it. Let's go. Axis symmetry. Let's go with Archie. What's my axis symmetry here? X equals what? Where would you cut on this to make it symmetrical? Yes, you're right. It's here, but not the -9. It's always x. So which one's my x coordinate? 0. That's my x coordinate. So you literally just say x equals 0. That's the vertical line that cuts at 0. That's as simple as it is. I'm telling you, there's something about axis symmetry. Too many students get it wrong. Next one, type of turning point. What type of turning point is this? Let's go, Rebecca. Minimum, correct. You got a minimum turning point because it obviously reaches the bottom and it goes back up. Coordinates of turning point. What's the coordinates? Let's go with Elsie. 0, -9 is correct. You got 0, -9. Y-intercept, Jack. 0, -9 as well. So this is one of the cases where both y-intercept and turning point are the same. And then lastly, which is the easy one, what is the x-axis intercept? Let's go with KL. Where does it cross the x-axis?
At 3, -3 is 0, and 3 is 0.
Very good. That's it. That's exercise 10E. Okay, so your job is to identify key features, and second skill, can you plot the coordinates and do it? All right? I'll stop the video there.